So that's a wonderful question. First off, your planner should be going home every day. So you should have your planner. What was that? Why? So I agree that it's large, but since almost everything lives in your binder, and taking things out of your binder to take them home and then putting them back in your binder when you go back to school doesn't really happen very often because you're in middle school, I can agree with your parents that yes, it's big, but that doesn't mean that you should be leaving it here. So that's up to you, but when that turns into a problem, I'm going to quote this conversation and say, I told you you should be taking your binder home. So if you come to the Phoenix page, staff, contact staff. Any of us on here, so say you want to contact me, click on me. There's my email, and we had phone numbers on here. We used to have phone numbers on here. Maybe they took them off. But yeah, so you should add them to your contact list, honestly. Yeah, we used to have phone numbers on here, but they probably told us to remove them because then people could, like, use our numbers for bad reasons. What's up? Yeah, she said if you don't have your plan book, how are you supposed to find your number? So you should have your plan book. That's the big thing, is you should have your plan book at home. All right, so did we talk about this problem at all? Did we get to start these notes?
Yeah.
Yeah, so we finished this one?
No. We were still discussing.
So did we find Juan's locations? So this problem I think is kind of really funny. I think these friends are screwing with one of their friends. You guys ever, like, messed with one of your friends? Yeah. You're like, oh, yeah, man, meet us at UDF. And you're not at UDF. And you're like, hee. So, I know you guys. So, we're at Amy's house, right? You're hanging out with friends at Amy's house. And one of your friends says, hey, guys, I got invited to Michelle's house. And I don't know where she lives. And you guys are like, oh, that's easy. So, you know Juan, right? And he's like, yeah, I know Juan. He said, so Juan lives 2.5 blocks from here. So in your head, you're like, okay, 2.5 blocks from here. Well, what's the problem with a statement 2.5 blocks from here? You don't know which way. So if we're going 2.5 blocks to get to Juan's house, well, 1, 2.5, this could be Juan's house. 1, 2.5, this could be Juan's house. So your friend is kind of annoyed, but at the same time, he's like, you know what? I can handle this. I've only got 2 possible locations. If I have to knock on 2 different doors, who cares? You ever knock on the wrong door, it's not a big deal.
Yeah.
So then they say, okay, so you know Juan's house. And you're like, okay, yeah, sure. And they say, okay, so Michelle's house is 3 3/4 blocks from Juan's house. And you're like, oh, okay. Well, so if I go here and this is Juan's house, where could Michelle's house be? Abby? 3 3/4 blocks positive, right? So if I'm here, let's go 3 and then go 3/4. So 1, 2, 3. Then let's do our 3/4. 1/4, 2/4, 3/4. So Michelle could live here. Or she could live 3 3/4 on the other side. 1, 2, 3. 1, 2, 3. Okay, so that's if Juan lives here. But we don't know where he lives yet. So if Juan lives here, then Michelle could live 3 3/4 blocks, again, in the positive direction or to the right. So I start here and go 3 3/4. 1, 2, 3. 1, 2, 3. So Michelle might live here. Again, this is Amy's house, we know. Or Michelle could live 1, 2, 3. 1, 2, 3. Looks like right out here. So Michelle could live there. So we end up with 4 possible locations for Michelle's house, and your friends are jerks, is kind of what that makes it seem like. Wouldn't you think so, Mr. Sherg, if your friends give you 4 possible locations for somebody's house? That's really difficult to find. So that is why specificness in directions is vital. North, south, east, west, positive, negative, to the right, to the left. Anything like that, those vocabularies that give you those defining details are very important. I try to pull him into math problems anytime I can, but that wasn't a very good one. I'll like ask him questions like, what's the square root of -47? Which can't happen. Can't square root negative numbers, by the way, for what it's worth. So I want you to try that, except now we know where Amy, Juan, and Michelle live. So now you get told Paul's house, but they've learned, because you got on them, they've learned some detailed vocabulary. They've learned some detailed vocabulary to help you out. They're trying not to be jerks today. Yeah.
Michelle's house is right next to Amy's house. Why didn't Amy just said it's the house?
Because they were being jerks.
Yeah.
I told you, sometimes your friends are jerks and they think it's funny, and you have to deal with it because they're your friends.
Yeah, and you could have just said, oh, they're to the side of us, and they keep.
I know, they could have, but that doesn't mean that they will. Welcome to middle school. One thing that I've learned about middle schoolers in my years working with you guys is sometimes you like to make things really complicated when they don't need to be, hence that situation. That's making things very complicated when they could have made it quite simple. Now, what is our defining detail here? What have they provided us about Paul's house that we didn't have previously? Izzy? Says it east. Now, that creates a whole other problem. You have to know your direction, your coordinate directions of north, south, east, west. So a lot of times on a map, you'll see something called a legend, not Zelda. You'll see something like that that's called the legend. Now, what does that actually do? It normally has something else with it. Where's my Boy Scouts in the room? How do you remember your coordinates? What direction is where? Do you have a little phrase for it? So, north, most of us know, is up. And the phrase that you can remember, and I would draw this on your paper because it will help you guys, is never eat soggy waffles. Or never eat sour watermelon. Anyone know any of the other ones? Never enter Santa's workshop. There's a lot you can remember. Going clockwise around your compass. Never enter Santa's workshop is the one that I always liked because I thought it was humorous. So whatever you use to remember, east is in the positive direction on our number line. So we have to go 1 3/4 blocks east from Michelle's house. So do your 1, then do your 3/4, 1/4, 2/4, 3/4. And it looks like either Paul somehow lives in the alley or this is his house. Maybe he's camping. Yeah.
Or it could be never eat Santa's waffles.
Yeah, never eat Santa's waffles. Never eat sushi with wasabi.
Never eat stale waffles.
Hmm.
Or never eat Santa's waffles. What? Never eat salty waffles.
So, you guys can think of whatever funny phrases you want to remember that, but you will need to know your coordinates north, south, east, west when you are doing things in social studies. So try to remember those with whatever method works for you. So now we're going to deal with temperatures. Anyone watch the news? You ever watch, in the winter, you probably maybe watch the news a little bit more. Why do you watch the news a little bit more in the winter, probably? Snow days. Now, a couple years ago, we had a few days that were not snow days, but we were not at school. There was barely any snow, actually. It was not winter break. Good thinking, though. That's creative. Yeah,
Maybe it was just icy.
it wasn't icy, actually. Actually, the roads were quite fine. The roads were easy to drive on. Service?
Is it wind chill?
Temperature. Yeah. The wind chill, which actually I have a little chart I'll bring in and show you guys how to determine wind chill. It's really useful. The wind chill, or the temperature, was so low that it was, honestly dangerous. Go to the hospital dangerous for anybody to stand outside for any length of time. I went to the grocery store, and just walking into and then out of the grocery store, your face hurts from how cold it is. So that's why we didn't have school a couple years ago, a few days, just because how cold it was. So it was less than 0. Literally, the wind chill was negative temperatures. So yeah.
Yeah, I thought that it was just a snow day, so I kind of ran out there.
Yeah, and then you realize.
And then dove into the snow. It's so cold.
Yeah. And ice doesn't even really form, because for ice to form, there has to be water first. And those are the days where you see it's kind of oddly snowing just because there's ice crystals in the air. Like, it's really weird. Yeah.
Yeah, I remember, like...
Casey, right? Sweet, Casey. I just checking.
And I remember, like, that day, like, I was watching the news, or my dad was watching the news, or whatever, and, like, in New York or something, like, you could throw up, like, a cup of water.
Yep.
And, like, freeze.
Yeah.
Like, that's how
I did that a couple
Yep. Abby?
I know, like, if it's, like, below zero, like, you can't go to school if, like, the temperature is below
It determines it's more so the wind chill
Yeah.
because so that's the difference between air temp and wind chill. Wind chill is what it feels like, and that's also then I forget what they call it when it's warm outside. Heat index. They call it the heat index. So say the temperature is 90, but the heat index is 105, which means with the humidity, with the sun, with everything else, it feels like it's that temperature when it's actually this temperature. So wind chill will always be lower than the actual temperature. Yeah, real quick, then we got to move on, Izzy. Did you go to school? Oh. Oh, okay. Yeah, so using that as a reference point, we like records. Don't know why, but we as humans like records. Longest jumps, highest, like tallest person, whatever. And temperature, ever since we've been able to record temperature, is an interesting thing to follow. Global climate change, we'll get into that this year too. But that's one of the reasons we follow temperatures is to see what's happening with our Earth. So we want to talk about variation from normal. So we want to write an equation to determine variation from normal. And the terms that we have to use to find variation is the recorded temperature and the normal temperature. Now, if I want to find the variation, and variation could be positive or negative, because if it's negative, what would that be communicating if my variation was negative? My variation from normal. What if that variation was negative? Like, what if this was a negative 26? If the variation was a negative 26 degrees, does that mean that your recorded temp would be higher or lower than the normal temp? If your variation is negative. By the way, yeah, thank you, Justin. Lower. If we get through this lesson, I give you the rest of class time for homework. So you guys sitting there like a bump on a log and not saying anything is not helping us progress through the lesson. If my variation is negative, that tells me that the temp was lower than what it normally is. If my variation is positive, like it is right here, that tells me that the recorded temperature is higher than normal. Now, how do they find normal temperatures? Normal is actually a bad word there. We're going to use normal, but what word should we really use? Lily? Average. So, averages, anyone remember how to get an average? Go ahead, Lily. You're really close. Correct it, Colin. Ooh. Okay, so we add them all together. So Lily, where you said multiply, we add them all together, then divide by how many terms there are. So if we had temperatures for 10 years, we'd take all of those temperatures, add them all up, like for January 15th or whatever the day is, and then divide by how many temps we have, and that would give us what the average temperature on that day would be. So we see the average temp was 15. The recorded temp on that day was 41. So the variation was 26. Now, how did they find their variation? We are going to use N for my normal and R for my recorded temperature. Shane? Yeah, what they recorded minus what the normal is. So that's going to be our formula that we use. So if I'm looking for my variation, I can just plug in the R and the N. So for this situation here, my variation will be when my recorded was negative 35 minus my negative 4. What happens when we have minus a negative? Jaheim, was that, or was it Xavier? I mean, just stick up a hand and Xavier. Yeah, plus a positive. So, don't forget the negative that did not get affected. The negative in front of the 35 did not get affected by that. So now I get negative 35 plus 4. Same sign or different sign? different. So we take the sign with more power, find the difference. So my variation was 31 degrees lower than normal, so we make it negative. Since it was lower than normal, we make it negative.
It's confusing because you change the subtraction sign to the addition sign and then change it back.
I did not change the subtraction sign. I took the subtraction and looked at it as the opposite of a negative value. And the opposite of a negative, or the opposite of a loss, is a gain, or a positive, or addition. So I took both of these. Don't think about changing the negative. I paired up the two negatives or opposites, or whatever you want to call them. That's how we got the plus. And this does not get affected, so it stays a negative. So I could do negative 35 way down here and add 4 and get to negative 31, but it's a difficult concept to understand that I can add positive amounts to a negative amount, because most people would try to say that this would be 39 and then make it negative, but that's not true. These numbers are doing opposite things. One's going negative, one's going positive. The negative has more power, but the positive brings the negative back a little bit. So it brings it 4 back towards 0, which makes it negative 31. Yeah, it's a weird process. Negatives are hard to work with. I agree with you. Any other questions, CJ?
Did you make those cards last night?
I did not. Sorry, I went for a 10-mile bike ride instead. I'll be honest with you guys. Yeah. Sorry, it was a nice night to bike, and my wife actually wanted to bike, so we went for a ride. Sometimes you got to do something for yourself. Guys, if you ever come and tell us, hey, I didn't get my homework done because I just couldn't do it last night. I'll do it tonight. Sorry. We get that. You're human beings. We know you're not machines. So just be honest with us. We're all here doing the same thing. You're just wondering if I'm ever going to call on you without you knowing?
Yep.
Yeah, you'll know when I have the cards. I shuffle them and make a big dramatic thing. Yeah, I'll have them by next week for sure. I just need to make myself do it. So I need to put it on my list. All right. Now, in this situation, we need to find R. Now, I'm going to introduce part of our equation solving lesson, which equation solving is more like chapter 7. So, if we want to find R, and come on, I'm waiting for it to, there it goes. My capture takes forever these days. We should get that RAM. I don't know if I should buy it and look for reimbursement or what, but let's chat later. So, by the way, if you're a computer geek, there's this program called Crucial. You should check it out. Talk to Mr. S. Huh? Crucial's free. But so Crucial tells you what you can buy for your computer. It matches you up with the right parts. So, I need some more RAM for this machine, and RAM is the computer's, power, essentially. So if I want to find R, let's check this situation out. Does this equation solve for R? What's this equation have isolated right now? What's it solving for? See?
It's not. No.
So yeah, no, it's not. What is it solving for right now? V, right? This is an equation solving for V. If I want to solve for R, I need to isolate the R. Now, in order to do this, and you guys may have seen this in 6th grade, you may not, you're coming from 11 different elementaries, I need to manipulate this equation to get the R by itself. Now, look at the R and ask yourself, what is going on with it? What is happening to it? What operations? What values? What is going on? So, what's happening to R? If I read this, it is R. Who can help me? Yeah, it's being subtracted by how much? By whatever n is, right? We don't know what n is, but it's being subtracted by whatever n is. How would I undo subtraction? I do not want this to happen. I want R by itself. So how do I stop subtraction from happening? What's the opposite, Jaheen? We add. So I'm going to add, and if I want to stop it from subtracting n, how much should I add? Surface? Add the n. So on both sides, we're going to add the n. Now, somebody yesterday told me, that they were used to, you would draw like a dotted line or a line and then draw like a line across, kind of make an upside down T. You can do that. The biggest thing with equation work is if I manually do something, I am manually adding the n. I have to do it on both sides. So guys, you should really write this workout because this is where we're going. Like this is going to give you a preview or a little taste of our like chapters to come. So now, a negative n plus a positive n. What are these called if you have a number and its opposite? They are, ooh, Justin? Oh, close. That's when we make it positive. You want to try again? It starts with A. You want to pass it off? Grace? Additive inverses, which what do they do when they combine? Cancel each other out and make 0. So my right side now is just R. What's my left side? Well, what happened to my V? It got an N added to it, right? So now my left side is V plus N. So to find the recorded temperature, I take the normal and add the variation, or take the variation, add it to the normal. So I come down here and say, okay, this R will be my variation plus my normal. So my variation was 4.2 plus my normal of negative 4.4. I have addition, which is nice. We like addition. Do they have the same sign or different signs? Different. So I take whichever sign is more powerful, the negative. And what's my final answer, Lily? Okay, question?
How did you get 4.2? 4.2 is the variation.
This is the variation. So it might make more sense for you guys if I work vertically. So 4.2 is plugged in from the variation. The normal temp was the negative 4.4. So I pulled these values from here to plug into my equation.
I thought you meant like there would be one for negative, one for normal, one for variation.
No. So does this make sense now? We're using these values.
Yeah.
So then, my negative is more powerful. The difference between 4.4 and 4.2 is just 2/10. And yes, I know I bounce back and forth between saying my decimals properly and saying the point version. As long as you are aware of how to say it properly, you can occasionally say it the point way. I don't really care that much, as long as you know how to say it properly. Biggest thing with equations, if you do something to one side, you have to do it to both sides. Kind of like if you work in childcare. If you give something to one kid, you have to give it to every kid. So I'm going to skip the got it. We'll come back if we have a chance. Range and interquartile range. Interquartile range. Weird word. Range is fairly easy. Colin, what is a range?
The range is the numbers, how long one separate part is. Like the interquartile range is.
Now hold on, let's back up to range. So you said range was what now?
The distance.
The distance. What numbers? Yeah, so it is the difference between, which difference is just distance. Difference between, here's the easy way to say it, minimum and maximum. Because I often abbreviate my and into just the and symbol. You can, if you want to get fancy, use the ampersand if you can draw it, but I can't. Well, I don't know if is that what it is?
Yeah.
Hey, look at that. But if you try to draw it small, it might get a little messy. So here, for range, my highest value, what do we want to say that is? 23, maybe? 23, probably. It's not too close to 25. And then my lowest value, let's just say negative 16.
Oh,
Yeah, it's past negative 15. It's hard to see. Let's just say negative 16. So, it's always easiest when we're doing a subtraction, because difference is subtraction, put your positive first. So if I do 23 minus the negative 16, this becomes addition. 23 plus 16, 39 is my range. Any questions on how I find my range?
I want to get this down.
Well, it's also on the TV. So now, interquartile range. Why do I keep emphasizing quart? What, Jaheim, does quart mean?
Well, it means
Like our graph is broken up into quartiles.
yeah.
Trying to think of other things. Foursquare quart is broken up into quartiles. Our pod is broken up into quartiles. You know it, you're going to pass it. I know, it's hard to get the words out sometimes. I know. How many quarts are in a gallon? You guys remember Big G Man? Or however you learned it? Xavier, help him out, man.
Okay, so there's 4, and so it's split into 4, so that's the interquartile.
Quart means 4. Quad or quart mean 4. So, it splits it into 4 ranges. 1, 2, 3, 4 ranges of data. Now, here's the interesting thing about how a box and whisker plot actually works. 25% of your data is in here. 25% of your data is in here. 25% of your data is in here. And 25% of your data is in here. Which means each of them have the same amount of numbers. So why aren't each of them the same width? If each section have the same amount of numbers, why aren't each of them the same width? Abby?
Because everything has like different like ranges.
Okay.
Like maybe like more people had this much of a range than other people did. And
Okay, so be careful by saying this much of range. I like what you're thinking.
like maybe like more people had like number 2's range, like that range of numbers.
Can I take
that-
what you're trying to say and kind of reword it? So what Abby's trying to spit out, it's hard to communicate. She's saying, so let's look at this as plays run. This is a football graph. Yards gained on first quarter plays. Can you lose yards?
Yes.
Yeah, it happens a lot, especially in middle school, high school. So these are lost yards. Sorry, gents, try not to do that unless you're on the defending team. So right here is where we start to gain plays. So 50%, more than 50% of my plays, we're gaining.
Are
25% of my plays, 1 out of every 4 plays, I am gaining between 6 and 8 yards. That's pretty good. If 1 out of every 4 plays I'm gaining 6 to 8 yards, that should get me to those first downs. 25% of my plays, though, I'm gaining between 8 and 23 yards. Those are great plays. But then, 50% of the time, if I look at this whole bottom half, I'm gaining between 6 yards to losing 16. So, what we're saying is more numbers are close together right here. If there were 20 plays that we were looking at, maybe it would be negative 16, negative 15, negative 14, negative 13, real easy, all right in there. Then when we shift to this fourth, like negative 8, negative 3, negative 2, positive 3, they're more spread out. But then when we get right here, it'd have to be like 6 and 6 and 7 and 7 and 8 and not, they'd have to be really, really close together. Does that make sense? Because these each represent the same amount of terms. They're either spread out or close together. Do we have questions? What does it mean? This is a far out question. You guys probably won't know this. If I didn't have a whisker, have you ever seen a box and whisker plot that doesn't have a whisker? Do you know what it means? So if this didn't have a whisker, that would tell me that this point was an outlier and that there weren't actually enough points in here to want to connect it. So most box and whisker plots have whiskers. But if you ever see one without a whisker, it's showing you that there's an outlier point that doesn't connect with the data well. Yeah. Huh? These are the whiskers. So this shows 25% of the data. The reason that we use the box is this is the center 50% of your data. So that's what we mainly look at is the core 50%. We ignore the bottom 25% and we ignore the top 25%. So like I was talking about an outlier. If we had an outlier, maybe on one play, Justin, what do you play? What position? What do you play on offense? There you go. So Justin's way out to the side. They don't see him. They pitch a lateral over to him, and Justin runs like over half the field. He runs a 65-yard touchdown run. Would that fit into the data that I have here? No. So that number would be way out here, not connected, and that would be the outlier point of Justin's 65-yard touchdown. So that would not fit into most of the plays. It's an outlier. It doesn't match my data. Does that make sense? Because that would be a really rare occurrence. That would be sweet, but that would be really rare. Did you guys see the play? I think it was a high school play that made last week that they, the dude did a flip over the other guy.
Yeah, I saw that.
Yeah, it was like all over SportsCenter. It was pretty cool. They're like, this is going to be the play of the season. And I'm like, guys, we're only like 2 weeks into the season. Calm down. So, IQR. We still haven't answered that. Interquartile range. This is easy. Way easier than what it makes it seem like. This is just the difference, because it's a range. Difference and the center 50% of data. Or you can say width of box. If you have a box and whisker plot, it is the width of the box. So here, I check where my bottom edge is. Well, -10. My top edge looks like it's at like 8. So I would take 8 minus the -10. Remember, it's going to have to be positive, so we can put it in absolute values. Or you just have to remember to make it positive. What's 8 minus a -10? What's that come out to be? 18. And it is positive, it stays positive. So my whole total range was like 30, what did we say it was, 32? But my interquartile, the main 50% of my plays, there's an 18 range there. So that range, your interquartile range will always be smaller than your full range because it's just the middle 50%. Any questions on interquartile range? It's the range between quartiles. And one last thing to label just so we have it. Technically, this point right here is called quartile 1. This middle split in the box is quartile 2. And can you guess what this edge is called? Quartile 3. So really, for IQR, it's just Q3 minus Q1. So it's the width of your box. Q3 minus Q1. Any last questions on interquartile range? Huh? 2, 4. What? Oh, no. So that's what's weird. We only have 3 quartiles because those are my split points. Notice that by cutting, let's say I have a pizza. I always have pizza. If I have a pizza that I want to cut into 4 quartiles like this, I cut 1, 2, 3 times. I only cut 3 times to make 4 pieces. So these quartiles are the cuts in my data. 25% of the data, cut it. 25% of the data, cut it. 25%, cut it. And the last 25 to your final value. I know, sorry. We were talking about Dutch oven cooking this morning, and now I'm really hungry to go camping. Anyone got big plans for Labor Day? Yeah? Good, good. Enjoy the 3-day weekend. Get out of here. Go do something. So, here, when you're given a list of data and you're asked for the range, and we're actually going to do the interquartile range also. Can I find my range with how the data is listed out right now? Shane, you're shaking your head. Why not? What's bad about this? It's what? Yeah, it's out of order, right? We don't. So by order, how do numbers like being ordered? What is nice to do with numbers? Yeah. Yes, I don't have it. Bella. Least to greatest or greatest to least, right? They want to work like they're on the number line. So I gotta start figuring out what's my lowest value here.
Ooh, I know.
What?
-2.
-2. Then cross it out so we remember that we used it. Then a -1. I'm gonna shift over before I already run out of space. And then I have another -1. I have a 0. I think 3 is my next one, and then 5. And then 8, then 9, then 10. 12, 2 12s. A 13, a 14, and a 15. So to find our range, I have like 2 minutes left. To find our range, we'll deal with mean, median, mode when we get to central tendency of data. So we look at 15 to -2. Remember, we have to cross 0. So you can also think about 2 to get to 0 is 2. 0 to get to 15 is 15. So I know that my range will be 17. Now, IQR is where this gets a little bit more difficult. I'm going to do this real quick. I still have a minute. Please give me my minute. Teachable time is very important, especially since we chopped a minute off each class this year. So, crap. Did not mean to do that. I didn't mean to clear all of that. I'm just going to drag this down. Interquartile range. We have to break it up into quartiles. So, we first count our data values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I need to break this into halves. And then I need to break it into quarters. What's half of 14? Chill, man. It's half of 14. Anybody, we gotta move quick. 7, right? 1, 2, 3, 4, 5, 6, 7. I would split it right here. So that's my Q2. But then I need to find Q1 and Q3. This is where it gets weird, and I just want to introduce this. There's now 7. Luckily, it's odd, because 1, 2, 3, this is the very middle. There's 3 and there's 3. That's my Q3, or sorry, Q1. 1, 2, 3. This value, 1, 2, 3, it's got to be the very middle, and that's my quartile 3. So the interquartile range right here would be the difference between 12 and 0, just 12. Now I'm out of time. Have a great day. Your homework is already up and live. Please try to get it done. Let me know if you have any issues. Nice! Make sure it's to an 80%, please.